Sam Altman called India's AI ambitions totally hopeless. He wasn't insulting our engineers, he was quoting a price. Let me set the scene. In late 2023, Sam Altman, the CEO of OpenAI, sat at a conference and essentially said that trying to build a competitor to ChatGPT with just $10 million was, quote, totally hopeless.
Me. Sam, can you just going to startups? I mean, as you know, we've got a very vibrant startup ecosystem in India. Specifically focused on AI, are there spaces where you see, let's say, a startup from India building, you can build on the models, be it ChatGPT and many others. But if you want to build foundational models, how should we think about that? Where is it that a team from India, 3 super smart engineers with, not 100 million, but let's say 10 million, could actually build something truly substantial?
Look, the way this works is we're going to tell you it's totally hopeless to compete with us on training foundation models. You shouldn't try, and it's your job to try anyway. And I believe both of those things. I think it is pretty hopeless, but
a lot of people in India took that personally. They heard it as an insult to Indian engineering talent. But that's not what he meant at all. He was telling us something far more uncomfortable. He was telling us the price tag. Here's the myth. Indian engineers can't build something like ChatGPT. Here is the reality. India has some of the best machine learning researchers and engineers on the planet. Thousands of them work at Google, Meta, Microsoft, and OpenAI itself. The gap is not talent. The gap is capital and risk appetite. Indian companies and investors have rarely been willing to write checks large enough and absorb failures painful enough to train a frontier AI model from scratch. Let me walk you through exactly why this costs so much, step by step, using a 5-step framework I think of as the true cost pipeline. By the end, the number will shock you, but it will also make perfect sense. Step 1. Understand what a model actually learns and stores. When you train an AI model like GPT-4 or ChatGPT, the model stores everything it learns inside things called parameters. A parameter is just a number, a tiny dial that the model adjusts during training. There are 2 types, weights and biases. Think of weights as the strength of a connection between 2 ideas, and biases as a nudge that helps the model lean one way or another. Here is the pipeline for how learning gets stored. Raw training text flows into the model. The model makes a prediction. It checks how wrong it was using a loss function, and then it nudges millions of parameters slightly to be less wrong next time. That cycle repeats billions of times. More parameters generally means the model can capture more nuance, more subtlety, more of the messy complexity of human language. A small model might have 7 billion parameters. GPT-4 is estimated to have around 1.7 trillion parameters. That is roughly 240 times larger. Step 2. Measure the compute you actually need. Training is not free thinking. It is raw math. Every single adjustment to every single parameter requires arithmetic, multiplications, and additions running on specialized chips. We measured this work in flops, which stands for floating point operations. One flop is one tiny math operation. To train even a modest 7 billion parameter model, you need somewhere in the ballpark of 40 to 50 billion flops. That is not a typo. That is a number with 19 or 20 digits. The pipeline here goes like this. You take your parameter count, multiply by the number of training tokens, which is roughly how many chunks of text you feed it. Apply a scaling constant, and you get your total flop budget. This number is fixed by the laws of math. You cannot negotiate it down. Step 3. Face the hardware bottleneck. The best chip in the world for this job right now is the NVIDIA H100 GPU. On paper, a single H100 can perform about 989 teraflops per second. That means 989 trillion tiny math operations every second. Sounds incredible, right? Here is the catch. In practice, you only get about 40% of that, roughly 395 teraflops per second. Why? Because the memory that feeds data to the GPU cannot keep up with how fast the GPU can chew through it. It is like having a race car engine attached to a garden hose for fuel. The common mistake here is assuming you get peak performance from your hardware. The fix is to always plan for 35 to 45% utilization, which is what real-world benchmarks consistently show. Step 4. Do the actual dollar math. When you divide your total flop budget by the realistic throughput of one H100, you land at roughly 30,000 continuous GPU hours to train one 7 billion parameter model, one training run. Cloud providers like AWS, Azure, and Google Cloud rent H100s for roughly $2 to $4 per hour in 2025. So 30,000 hours times, say, $3 gives you about $90,000, or roughly 75 lakh rupees. That sounds almost reasonable, right? Here is where it gets painful. You do not train a model once. You train it, find problems, adjust your data, tune your hyperparameters, and train again. Realistically, 3 to 5 full retraining runs is normal. So that 75 lakh becomes roughly 4 to 5 crore rupees just for a 7 billion parameter model, a model that is still 240 times smaller than GPT-4. Step 5. Scale to the frontier and see the real bill. GPT-4 with its estimated 7 trillion parameters and its mixture of experts architecture is in a completely different universe of cost. The best public estimates put the training cost of GPT-4 at over $100 million. That is on the order of 2,500 crore rupees. And that is just training. That does not include the thousands of human labelers for reinforcement learning from human feedback, the data licensing, the infrastructure team, or the inference costs of actually serving the model to millions of users. Now let me give you a real example. Sarvam AI, an Indian startup founded by former Google and AI4 Bharat researchers, has been building large language models focused on Indian languages. They are brilliant engineers doing important work, but even with strong venture funding, they are operating at budgets that are a fraction of what OpenAI, Google, or Anthropic spend on a single training run. Ola Scrutiny made headlines with bold claims, but the gap between announcing an AI model and training a genuinely frontier class one is measured in thousands of crores. Here is the honest pitfall. Even if an Indian company raised 2,500 crore for training, there is no guarantee the model works. OpenAI reportedly had multiple failed training runs before GPT-4 came together. That money can simply evaporate. In Silicon Valley, investors understand and accept that risk. In India's investment culture, a bet that large with that much uncertainty is extraordinarily rare. The transformed outcome, though, is worth imagining. If India could muster the capital and the risk tolerance, there is no technical reason Indian teams could not build a frontier model. The talent exists. The research chops exist. What is missing is someone willing to write a check for 2,500 crore, accept that it might fail, and try again. Sam Altman was not mocking India. He was stating a financial fact, and until we treat this as a capital problem instead of a talent problem, we will keep sending our best engineers to build someone else's ChatGPT. If you found this breakdown useful, you can find more of my work at jprasad.com.